Imagine Southeast Asia millions of years ago, during the Miocene epoch. Warm, humid forests were teeming with life, and amongst the leafy branches lived small, agile primates, our story's protagonists. These weren't the gibbons we know today, but their early ancestors. They were tree-dwelling experts, swinging through the canopy with impressive speed and agility. Their lives, much like the forests they called home, were about to undergo a dramatic transformation. This is where the fascinating, albeit speculative, journey of Bigfoot begins. These early primates were small, perhaps not exceeding 3 feet in height. Their diet consisted primarily of fruits, insects, and leaves, found readily in the plentiful rainforest. Life in the trees provided a degree of safety from predators, but also presented its own set of challenges, shaping their evolution in profound ways. Over time, competition for resources and the ever-present threat of predators would drive these primates down from the safety of the canopy and onto the forest floor. This shift in habitat marked a turning point, setting the stage for the evolution of a creature of immense size and strength, the legendary Bigfoot. In the heart of the rainforest, a silent force began to shape our ancestral primates' evolutionary pressure. Food, as always, was the ultimate prize. Larger primates could reach more fruits, access hidden resources, and outcompete smaller rivals. This competition spurred a gradual increase in size generation after generation. However, food wasn't the only driver. Predators, ever lurking, posed a constant threat. Larger size meant better defense, a more intimidating presence, and an increased chance of survival. Over time, larger primates thrived while smaller ones struggled, further fueling the trend toward gigantism. But the shift to a larger size wasn't just about winning fights, it also opened up new dietary possibilities. Larger primates could exploit a wider range of food sources, including tougher vegetation and maybe even small animals. This dietary shift in turn further contributed to their increasing size. Life in the complex three-dimensional world of the rainforest demanded more than just brute strength. It required cunning, an ability to learn and adapt. The ancestors of Bigfoot were not just growing larger, they were becoming smarter. The rainforest presented a constant stream of challenges, navigating the dense foliage, remembering the location of fruit trees, and outwitting predators. These challenges favored individuals with greater cognitive abilities. Those who could learn and adapt were more likely to survive and pass on their genes. Social complexity played a crucial role as well. Living in groups provided protection from predators and improved efficiency in finding food. But it also required individuals to navigate complex social hierarchies, recognize individuals, and cooperate within the group. These social pressures further stimulated the development of larger brains and greater intelligence. This growing intellect likely manifested in early tool use. While evidence is scarce, it's plausible that these primates used sticks to extract insects, rocks to open nuts, or even leaves as rudimentary tools. This early tool use, however rudimentary, would have further stimulated cognitive development, setting the stage for the intelligence often attributed to Bigfoot. Section 4. Strength in every step. Adapting to life on the ground. As our primate ancestors grew larger and bolder, they began to spend more time on the forest floor. This transition from a predominantly arboreal life to a more terrestrial one had a profound impact on their physical development, leading to the increased muscle mass we associate with Bigfoot. Walking upright on 2 legs, while initially energetically demanding, freed their hands for carrying food, using tools, and potentially even defense. This shift to bipedalism favored individuals with stronger leg muscles and a more upright posture. The change in diet also played a role. While fruits and leaves remained important, the forest floor offered access to roots, tubers, and potentially meat, all requiring greater strength to acquire and process. This dietary shift selected for individuals with increased muscle mass, particularly in the arms and shoulders. Finally, sexual selection likely played a role in shaping their physical appearance. Larger, stronger males would have had an advantage in competition for mates, passing on their genes for increased size and strength. This process over time would have further accentuated their muscular physique. Section 5. The long journey crossing continents. This brings us to one of the most intriguing and speculative aspects of the Bigfoot story, their journey to the Americas. While the fossil record tells us that early hominids, our ancestors, did migrate out of Africa and into other parts of the world, the idea of a large primate like Bigfoot crossing continents seems implausible. One possibility, albeit unlikely, is that during periods of lower sea levels, land bridges may have temporarily connected Asia and North America. These bridges could have allowed various animals, including our hypothetical primate ancestors, to migrate across continents. Another, perhaps even more speculative possibility is that they may have crossed bodies of water on rafts of vegetation. While this might seem far-fetched, it's not entirely implausible. Large storms can occasionally tear away vast mats of vegetation, which then drift across oceans, potentially carrying animals with them. It's important to note that these scenarios are highly speculative and lack definitive evidence. However, the possibility, however remote, adds a layer of intrigue to the Bigfoot story. Section 6. A new home, settling in the Americas. Assuming our primate ancestors did manage to reach the Americas, they would have encountered a landscape remarkably different from the steamy rainforests of Southeast Asia. The vast, temperate forests of North America, while offering new opportunities, also presented new challenges. The cooler climate and distinct seasonal changes would have demanded physiological adaptations. Thicker fur, for example, would have provided insulation during the colder months. Their diet likely shifted as well, incorporating more seasonally available foods such as nuts, berries, and perhaps even fish. This new environment, with its own set of predators and prey, would have continued to shape their evolution. The relative isolation of the Americas, separated from their ancestral homelands, would have further driven their evolution along a unique trajectory.